Close your eyes for a moment and imagine leaving Earth behind. The familiar blue glow of oceans, the swirling white clouds, and the comforting warmth of the sun slowly fade as you drift outward beyond the edge of our solar system. Past Mars, past the icy giants of Jupiter and Saturn, farther still beyond Neptune, and then out into the silent deep, the interstellar sea. Here, space stretches endlessly. The stars, once tiny pinpoints in our night sky, become distant suns, each one with its own family of planets. It is among these distant worlds, circling faraway stars, that we begin to wonder, what would life be like if it existed there? These are the exoplanets, worlds orbiting stars far from our own, some large and gaseous, others rocky and Earth-like. Some blaze close to their stars, bathed in heat, while others shiver in darkness on the edge of frozen space. In the last few decades, astronomers have discovered thousands of these planets using delicate methods that detect their shadows as they pass in front of stars, or by measuring tiny wobbles in a star's light caused by the pull of unseen companions. Each new detection is a reminder our solar system is not unique. Planets are common, scattered like pebbles across the cosmic shore. But among these many worlds, a question lingers softly: could any of them harbor life? Could oceans ripple on their surfaces? Could strange plants or creatures thrive beneath their skies? To imagine life on an exoplanet is not simply to dream of science fiction. It is to reflect on what it means to be alive in a universe so vast, and to consider that Earth may be only one chapter in a much larger story of life. As we set out on this journey together, we will move slowly, step by step. We will explore what makes a planet habitable, the strange diversity of worlds discovered so far, the possibilities of alien life forms adapted to environments unlike anything we know, and what it would mean for humanity to discover we are not alone. Tonight, let us drift gently into that imagination, letting the stars guide us outward. Before we can imagine life, we must understand what makes a planet capable of supporting it. On Earth, life thrives in a delicate balance. Liquid water flows in rivers and oceans. A stable atmosphere shields us from radiation, and a moderate distance from the sun provides warmth without burning us away. Astronomers call this the habitable zone, a region around a star where temperatures might allow liquid water to exist on a planet's surface. But habitability is not so simple. A planet's size matters. Too small, and it cannot hold on to its atmosphere like Mars, whose thin air leaves it cold and dry. Too large, and it may become a gas giant, smothered beneath thick layers of hydrogen and helium. Gravity must be strong enough to keep water from drifting away, but not so crushing that life cannot flourish. The type of star also matters. Stars like our sun burn steadily for billions of years, giving life time to evolve. But smaller, cooler stars, known as red dwarfs, dominate the galaxy. They burn for trillions of years, far longer than our sun, and they often host planets in their habitable zones. Yet these stars flare violently, sending bursts of radiation that could strip atmospheres away. Would life around such a star adapt, or would it be extinguished before it begins? Atmospheres play a crucial role. They regulate temperature, protect against harmful radiation, and provide gases for breathing. On Earth, our atmosphere contains oxygen and nitrogen, but on another planet, life might breathe something entirely different: methane, perhaps, or even hydrogen. And then there is the role of water. On Earth, water is essential to every known organism, but could life exist without it? Scientists have speculated that other liquids, methane on Titan or ammonia in colder environments, could serve as a medium for alien biochemistry. Perhaps life elsewhere does not mirror us at all, but writes its chemistry in a different script. The more we learn about exoplanets, the more flexible our definition of habitable becomes. It is not simply Earth-like conditions we must imagine, but a wide range of possibilities, worlds where life thrives in conditions that seem, to us, unthinkable. Not long ago, the idea of worlds around other stars was speculation. Astronomers believed they existed, but the tools to find them did not yet exist. That changed in 1992, when the first confirmed exoplanets were discovered not around a sun-like star, but orbiting a pulsar, the dense remnant of a dead star. These worlds were strange, bathed in harsh radiation, but they proved that planets existed beyond our solar system. In 1995, the first planet around a sun-like star was confirmed: 51 Pegasi b, a hot Jupiter orbiting perilously close to its star, completing an orbit in just 4 days. This was not the Earth-like twin astronomers had hoped for, but it shattered assumptions. If such unusual worlds existed, what else might be out there? Soon, the Kepler Space Telescope expanded our view. Launched in 2009, Kepler stared at a single patch of sky for years, detecting the faint dimming of stars as planets passed in front of them. By the time its mission ended, Kepler had revealed thousands of exoplanets, from rocky Earth-sized worlds to super-Earths and mini-Neptunes, unlike anything in our solar system. Now, with telescopes like the Transiting Exoplanet Survey Satellite and the James Webb Space Telescope, astronomers can study exoplanet atmospheres, searching for signs of gases that might suggest life: oxygen, methane, carbon dioxide in unusual combinations. For the first time in history, we are not only finding planets, but also beginning to read the chemistry of their skies. These discoveries remind us of an essential truth. The universe is teeming with worlds, and though most may be barren, even a fraction harboring life would mean countless alien ecosystems scattered across the galaxy. Each discovery is a whisper. We are not alone, not in the sense of existence, and perhaps not in the sense of life itself. Let us now imagine one such world. Picture a planet orbiting in the habitable zone of a distant star. As you descend through its atmosphere, you notice differences immediately. The sky may not be blue, it could glow green beneath a different spectrum of starlight, or shimmer red beneath a cooler, dimmer sun. Clouds may not be water vapor, but methane, ammonia, or exotic compounds unknown on Earth. Beneath you lies an ocean. It may stretch endlessly, covering the entire world, with no continents to break its surface. On such a water world, life could exist only in the sea. Vast microbial mats drifting like floating continents, or great ribbon-like creatures rising and falling through the currents, glowing faintly in the dark. Or perhaps the planet is tidally locked, with one side forever facing its star and the other trapped in eternal night. On the day side, scorching heat might boil seas into dense storms, while on the night side, ice fields stretch endlessly. In the twilight zone between, where warmth and cold balance, rivers of liquid water might flow, and life could cling to this narrow strip of habitability. Even the ground beneath your feet could feel alien. Plants, if they exist, might not be green. On Earth, chlorophyll captures sunlight best in our sun's spectrum, but on another world, vegetation might glow black, red, or even violet, tuned to the light of its star. Imagine walking through a forest of crimson leaves, or watching luminous tendrils unfold beneath a dim sun. Alien oceans, alien skies, alien light. The possibilities are endless, and in imagining them, we also reflect on our own world. Earth, with its blue skies and green forests, is not the only way life can appear. The diversity of possible worlds reminds us that life is not bound by a single recipe. When we imagine life beyond Earth, our minds often drift to Earth-like conditions, blue oceans, green forests, and mild air. But our own planet teaches us that life is far more adaptable, far more creative than we often give it credit for. On Earth, some of the most fascinating organisms thrive in the harshest, most unforgiving places. In the boiling hot springs of Yellowstone, microbes flourish in water so scalding it would burn human skin instantly. In Antarctica, beneath miles of ice, bacteria live in pitch darkness, feeding on minerals locked in stone. At the deepest points of our oceans, where the pressure is crushing and sunlight never reaches, strange glowing creatures drift through black waters. These extremophiles organisms that love extremes show us that life is not fragile. It is resilient. It adapts, reshapes, and thrives where we would never expect it. This truth opens the imagination when we consider exoplanets. A planet covered in frozen ice might still harbor liquid oceans beneath, warmed by geothermal heat. There perhaps alien microbes drift through mineral-rich waters, slowly evolving over billions of years. A world with methane seas like Saturn's moon Titan might give rise to organisms that use methane the way we use water. They might breathe hydrogen instead of oxygen, crafting a biochemistry unlike anything we know. Even radiation, something we fear as destructive, is not an absolute barrier. On Earth, there are microbes that survive in the ruins of nuclear reactors, feeding off energy where nothing else can live. If life can adapt to radiation here, why not beneath the flares of a red dwarf star, protected under rocks or oceans? Some scientists even speculate about biochemistries that seem alien to us life, based on silicon instead of carbon, or using ammonia instead of water. Such organisms might move slowly, think differently, or exist in forms we would not even recognize as alive. So when we look up at the stars and imagine alien worlds, we should not think only of comfortable Earth-like twins. We should imagine caves lit by alien bioluminescent oceans of methane, dotted with floating colonies, or frozen deserts where microbes wait patiently for warmth. Life may not only exist, it may flourish hidden in places our imagination has only just begun to reach. If life does exist on distant exoplanets, another question arises. Could we ever speak to it? Could two worlds, separated by light years, ever share a moment of recognition? The universe is vast, and distance is the first challenge. The closest star system to us, Alpha Centauri, is over 4 light years away. If we sent a message today, it would take 4 years to arrive. If an answer were sent back, another 4 years would pass before we received it. Communication would not be a conversation in real time. It would be a slow exchange, like messages in bottles drifting across a cosmic ocean. And yet, scientists have long dreamed of this possibility. The search for extraterrestrial intelligence, or SETI, has spent decades listening to the sky. Large radio dishes sweep through the heavens, searching for unusual patterns in cosmic noise signals that might hint at an intelligent origin. So far, the universe has been quiet. But silence does not mean emptiness. Perhaps other civilizations exist, but they are too far away. Perhaps they use methods of communication we cannot yet detect: laser pulses, neutrinos, or signals encoded in ways we have not imagined. Perhaps they choose to remain silent, watching quietly, waiting. Or perhaps, like us, they are just beginning to wonder if anyone else is out there. But communication does not need to mean spoken words or deliberate signals. It may come in more subtle ways. Imagine detecting an atmosphere with oxygen and methane together, gases that do not exist naturally in balance. On Earth, their coexistence is maintained by life. If we saw this pattern on a distant planet, it might be the first whisper of alien biology. Not a message written in code, but a message written in chemistry. Or imagine detecting something even stranger, a vast artificial structure orbiting a star, blocking its light in unusual ways. Some scientists have speculated about Dyson spheres, giant constructs built by advanced civilizations to capture starlight. Even the shadow of such a structure would be a form of communication, a silent statement that intelligence exists. In truth, communication may not be the exchange of words, but the recognition of presence. A signal, a chemical footprint, a shadow in the light of a star, all would say the same thing. We are not alone. To imagine life on exoplanets is also to confront deep philosophical questions. What would it mean for humanity to know beyond doubt that we are not alone? For centuries, humans have placed themselves at the center of existence. Once, we believed Earth was the center of the universe. Then we learned that Earth orbits the Sun. Later, we discovered the Sun is only one star among billions in a galaxy, itself one galaxy among billions. Each step has humbled us, showing that we are not the center, but a small part of something far larger. The discovery of life elsewhere would be the next step in that journey of humility. It would remind us that Earth is not the only cradle of biology, and that our story is not unique. Life, it would seem, is not an exception. It is a natural expression of the universe itself. But beyond humility, such a discovery could bring comfort. To know that the cosmos is alive in more places than one is to feel less isolated, less singular. It would mean that the patterns of chemistry and physics give rise to something more, that the universe has a tendency to create not only stars and planets, but organisms and perhaps even consciousness. Religions, philosophies, and cultures would grapple with this truth. Some might resist it. Others might embrace it as proof of a better design. But for all of humanity, it would expand our sense of belonging. We would no longer be the only voice in the dark, but part of a choir. And even without proof, the act of imagining life beyond Earth is valuable. It is a mirror. When we wonder if alien beings tell stories or dream beneath alien skies, we are really asking about ourselves. What is it that makes life meaningful? Is it survival? Is it thought? Is it the ability to wonder at the stars? Perhaps in the end, the question of alien life is not only about them, it is about us, about what it means to live, to think, to reflect. Imagining life elsewhere forces us to ask, what is essential and what is unique to Earth? And in this quiet reflection, we begin to see life not as a rare accident, but as a gentle thread woven into the fabric of the cosmos. Why do we search for exoplanets? Why do we point our telescopes outward, straining to see worlds we may never reach? Part of the answer is curiosity. Humans are explorers by nature. From the first time our ancestors crossed rivers, to when they sailed across oceans, to the moment we sent spacecraft into the solar system, we have always looked to the horizon and asked, what lies beyond? Exoplanets are the newest horizon, distant but tantalizing. Exploration is also about connection. Each new planet discovered reminds us that Earth is not alone, that it, too, is one among many. When the Kepler Space Telescope revealed thousands of planets, it reshaped our vision of the universe. No longer was Earth exceptional for having worlds around its star. Instead, planets are common, billions upon billions scattered through the galaxy. Future exploration may go further. Missions like the James Webb Space Telescope are already studying the atmospheres of distant planets, searching for signs of life. In time, we may send robotic probes, tiny spacecraft pushed by powerful lasers, sailing for decades across the interstellar void. Perhaps one day, long in the future, humans themselves will cross that distance, settling on new worlds. But exploration is not only about reaching, it is also about imagining. Even if we never walk on an exoplanet, the act of picturing its skies, its seas, its creatures, enriches our spirit. It gives us stories to tell, dreams to hold, and a sense of belonging to a universe larger than we can see. And there is one more reason. By exploring outward, we reflect inward. When we search for life beyond Earth, we are also asking, how precious is life here? How rare is this blue planet with its oceans and forests and fragile atmosphere? Exploration makes us not only adventurers, but caretakers, reminded that Earth too is a world among many, and that we must protect it. Pause for a moment and think about the scale of the universe. There are more stars in the cosmos than grains of sand on every beach on Earth. And around many of these stars, there are planets, some small, some large, some hot, some cold. The number of possible worlds is beyond comprehension. Among this vastness, what are the chances that Earth is the only place where life has taken root? Perhaps the answer is that life is common, arising wherever conditions allow. Or perhaps it is rare, scattered across light years of emptiness. Either way, the scale itself fills us with wonder. When astronomers discover a new exoplanet, it is not just a data point, it is a possibility. Each one could hold oceans, mountains, skies, perhaps even life. Even barren worlds remind us of nature's diversity, the creativity of the universe in shaping countless forms. And if life exists elsewhere, it may not mirror ours. Some worlds may host simple microbes, unseen but thriving. Others may nurture forests of strange plants, or seas filled with creatures that shimmer in alien colors. Perhaps, though less likely, there are even intelligent beings, societies with their own histories, their own dreams, their own sense of wonder beneath their stars. We may never know all the answers. The universe is too large, too ancient, too mysterious. But perhaps that is not the point. The beauty lies in the possibilities themselves, in knowing that when we look at the night sky, every star could be a sun with its own family of planets, and that among them, some may be alive. As we come to the close of this journey, let us pause in stillness. Imagine yourself drifting above a distant exoplanet. Its sky glows a strange color, shaped by a sun unlike our own. Beneath you, oceans stretch, or deserts glitter, or forests shimmer in alien hues. You do not know if life exists here, but the possibility itself is enough to fill you with wonder. Above the stars shine in silence. Each one is another world, another possibility. The universe feels infinite yet intimate, as if each light in the sky is whispering a story. You realize that Earth, our fragile blue planet, is one of these lights for someone else far away. Perhaps they too look outward and wonder if anyone is there. The search for life on exoplanets is not only about discovery, it is also about reflection. It reminds us that life is precious, that it thrives in resilience and diversity, that it may not be confined to Earth alone. It humbles us, expands us, and fills us with a sense of connection to the cosmos. So as you breathe slowly now and let your mind rest, hold on to this thought. Somewhere beneath a distant sky, life may already be looking back, and in that quiet symmetry across light years of space, we are united not in words, not in signals, but in the shared fact of existence. And that, perhaps, is enough.